Hello friends, so after completing the Green's theorem, now we are gonna start with the numericals based on Green's theorem. So let's see how to solve the numericals which are based on Green's theorem and how to apply the statement of Green's theorem. So let's see. So here we have to verify the Green's theorem for given f bar, that is x square I minus xyj, and C is the triangle. So C is basically a curve which is triangle having the vertices 0, 2, 2, 0 and 4, 2. Now guys, before verifying the Green's theorem, let's see what's the Green's theorem. So here on the screen you can see the Green's theorem. So guys, I will request all the students that before starting with this numerical, you have to go back to my previous video where I've derived the theorem of Green's, and now here I'll just consider the statement of Green's theorem, and based on that we will solve this numerical. So what Green's theorem says, he says that if P and Q are two functions of x and y, and let's say dou q by dou x and dou p by dou y are the continuous single valued function or the partial derivatives of this P and Q over the closed curve C, then we say that integral over a closed curve C P dx plus Q dy is equal to double integral over the region R dou q by dou x minus dou p by dou y dx dy. So this is what the Green's theorem. Now guys, this same Green's theorem can be given in the vectors form like this, where what do we do is we put f bar as pi plus qj and dr bar as dxi plus dyj. Now guys, we know that r bar is a position vector which is given by, here I'll write it down for you, which is xi plus yj, and therefore dr bar will become dxi plus dyj. Now if I take the dot product of f bar and dr bar, then we will get p dx plus q dy. So we know that we multiply the I terms and then j terms. So p into dx, that is p dx, plus q into dy, that is q dy. It means guys, this integral f bar dot dr bar is nothing but integral p dx plus q dy, and this is, we have seen in the previous videos, which is called as line integral. So basically it's a line integral. So it means we can say that this integral p dx plus q dy is equal to integral f bar dot dr bar. So this is what the vector form is, and here we find out the curl and we multiply it with the n bar, where n bar is a unit vector along the z axis. So guys, this is the vector form of Green's theorem. Now what we have to do is we have to verify the Green's theorem. It means we are going to verify this statement. Now to verify this statement, we should have the values of P and Q. But if you will see the question, then here the value of f bar is given. So we know that f bar in Green's theorem is pi plus qj. So we can say that here this x square, which is along the I, is my p, and xy, that is negative xy along j, is my q. So here I'll start from there. So f bar is given as x square I minus xy j. So comparing with that f bar, here I write down. So comparing with the value of f bar, we will get p equal to x square and q equal to negative xy. Now guys, after this we know the integral. So left hand side is clear, but for the right hand side we have to find out the value of dou q by dou x and dou p by dou y. So let's find it out. So value of dou p by dou y is 0, because if I differentiate p partially with respect to y, then here there is no y. So that is why the derivative is 0. Similarly, if I find out dou q by dou x, then here I'll get negative y, which is constant, and derivative of x is 1. So value is negative y. So I got these two values which I'm going to use for right hand side. Now guys, what is meaning of verify the Green's theorem? So it means we have to prove that the value of the integral on the LHS and the value of double integral on the RHS is exactly same. So then we can say that Green's theorem is verified. Now guys, to find out the value of this integral on the LHS, which is nothing but integral f bar dot dr bar, which is nothing but a line integral. What we are gonna do is we are gonna draw this given curve, and then we are gonna find out the line integral along each and every line or along each and every curve. So then we will add all those line integral and we will get the value of LHS, and then we will solve the RHS. Or we may start with the RHS, where on the RHS we have to evaluate the double integral, and then we'll solve the LHS and we'll prove the value of both sides is equal. So let's start. So here on the next page I'll draw the given curve. So here it is given that C is a triangle having the vertices. So first vertex is 0, 2, then 2, 0, 4, 2. I'll plot it on XY axis randomly. So here I'll say this is Y axis, this one is X axis. Now let's plot the point. The first point, that is A, is 0, 2. So it will come on the X axis. So let's say this one is 1, then 2, then 3 and 4. 1, 2. Now let's start. The first point is 0, 2. So that will lie on Y axis because the X coordinate is 0. So this is A. Let's find out B. So here B is given as 2, 0, which will lie on X axis. So 2, 0, this point. So this will become B. Then 4, 2. So X is 4 and Y is 2. So here X is 4, 1, 2, 3, 4, and Y is 2. So this point will be intersection of these two lines. So here we'll get C. And guys, if we'll connect these 3 points, then we will get a triangle. So guys, what we are doing here is we are drawing that graph by taking the manual readings. So now the coordinates of C we know it is 4, 2. Coordinates of B, that is 2, 0, and A is 0, 2. Now guys, here I have to find out the LHS. So this is the left hand side, and which is nothing but the line integral. So first of all I'll start for this one first curve, that is AB. So here AB is a straight line. So for AB, if I want to find out the line integral, then I have to find out the relation of y with respect to x. So here this is a straight line, and for straight line we know the equation of straight line in 2-point form is given by, so here I'll write down for AB, which is a straight line, the equation is given by y minus y1 upon y1 minus y2 equal to x minus x1 upon x1 minus x2. So guys, this is the equation of a straight line in 2-point form. So along the line AB we have 2 points. So for these 2 points, we can, using these 2 points, we can find out the equation of line AB. So I can consider these points as x1 y1 and these points are x2 y2. So let's start. This will become y minus y1. So this is x1 y1. So y1 is 0 minus y2. So this is x2 y2. Y2 is 2 equal to x minus x1. So this is x1 y1. So this is x1. X1 is 2 minus x2. X2 is 0. Let's solve this. So here we will get y by negative 2 is equal to x minus 2 upon 2. So guys, here I can cancel 2 with 2. We'll do the cross multiplication. So y into 1 will be y, and this will become negative 1 into x, negative 1 into minus 2, that is plus 2. So guys, we can say that it is nothing but x plus y equal to 2. That is the equation of the straight line. Or I can say that y is equal to minus x plus 2, or y is equal to 2 minus x. So now guys, I got the relationship between y and x, or I got value of y in terms of x. So using this, I am gonna find out the value of dy. So here I can say that the value of dy is minus dx. So I'll be using this relation in the integral. So we have to find out integral, that is p dx plus q dy over the curve. I'll say here AB, because we have to give the name to the curve. So I can say C1, C2, C3, because here guys, I'm going to find out the line integral along AB, then along BC, and then along AC, and then we are going to add it to get the total line integral. So first I'm finding along AB. So this will become integral now P dx. The value of P which we got here is x square, and the value of q we got here is negative xy. So let's put these values over there. So p is x square into dx plus, now q is negative xy, so I'll say negative x into y, but the value of y is 2 minus x, which we got along AB, into dy. So value of dy is negative dx, so here I'll say negative dx. So guys, what I'm doing is basically here we have integration with respect to x as well as with respect to y, but when we'll substitute the limit, it will be for x or for y, so it will become very difficult to solve the integration with respect to two variables. So that is why what we are doing is we are converting the given function as a function of x or a function of y, and we are converting the integration with respect to only one variable. So here what I did here is I found y in terms of x, and then I converted all y terms in terms of x, and I've converted all dy terms in terms of dx. Now we just got a term dx. Now guys, let's decide the limit. So whenever we are integrating with respect to x, the rule says that we have to take limits for x. So along this line, if you'll observe, then x is varying from 0 to 2. So guys, I'm finding along this direction, then we'll find along this direction, then we'll find along this direction. So along this line AB, x is varying from 0 to 2. So here I'll say x is from 0 to 2. Now guys, let's say if you are considering x as 2 minus y, so in that case you will be converting all x terms into y, so that time you will be getting dy. So whenever you are finding dy, you have to consider limits of y. So that time the limits of y will be 2 to 0, because along this line y is varying from 2 to 0. So this will become 2 to 0 for y if we are considering the dy terms or y terms. Now let's solve this integral. So this will become negative 2x, and this will become, or what I'll do is I'll take this negative sign with this negative sign, that will become plus. So here I'll write down that integration 0 to 2, this x square dx term as it is, plus this minus and minus will become plus, and x into 2, that is 2x, and x into minus x, that is negative x square, and dx as it is. Next, dx I can take it common, then in the bracket we will get x square plus 2x minus x square, x will cancel, will get 2x, so which is nothing but integral 0 to 2, then 2x into dx. Now what is the integration of 2x guys? So 2 as it is, integration of x is x square by 2, and it is over 0 to 2. Now 2 and 2 cancel, let's put value of 2. So guys, here we'll get 2 square, which is 4, and when we'll put lower limit as 0, we'll get 0, and therefore answer is 4. So therefore we got the line integral along AB as 4. Now let's find it out for BC and then for CA, and then submit all. So I'll say for BC. Now guys, here again BC is a straight line, so to get the value of y in terms of x, we have to find out the equation of a straight line. And to find out the equation of straight line, I'm going to use the same result. So here let's assume this has x1 y1 and this has x2 y2. So I'll write down the formula directly. So that will become y minus y1. So y1 is 0. So we'll get y minus 0 upon 0 minus. Now here we require y2. So guys, y2 is 2 because this is x2 y2. So y2 is 2. Here we'll get 2 equal to x minus x1. So here we require x1. So x1 is 2 and x2 is 4. So we'll get 2 and 2 minus 4. So 2 upon 2 minus 4. So therefore I'll say that is, this will become y by negative 2 is equal to x minus 2 upon negative 2. It is cancelled and guys will get y equal to x minus 2. So here I got the value of y in terms of x. So let's find out dy. So dy will be dx and derivative of minus 2 is 0. So guys, we got the value of dy as well. So let's find out the integral along BC. So it is p dx plus q dy equal to. So let's start guys. So value of p is x square. So that will be as it is. So x square dx as it is. Integration. Then plus the value of q is negative xy. So negative x and y I'll substitute by x minus 2 because here we got the value of y. And then we have dy term. So dy is dx. Now guys, I've converted the whole integration in terms of x. So therefore we have to take the limits of x. So here along BC you can see that x is varying from 2 to 4. So you have to go through this direction. So I'm going through B to C. So either you take this anti-clockwise direction or take the clockwise direction. So I've considered this anti-clockwise direction. So I got the value of AB along this direction. Now I'm finding BC along this direction. So along this direction x is varying from 2 to 4. And guys, therefore here I'll say x is from 2 to 4. Now let's evaluate the integration. So this will become integral 2 to 4. X square as it is, this is negative x square and positive 2x. Now guys, negative x square and this x square will be cancelled and we will get only positive 2x and dx. So let's find out the integration. So this will become 2 outside. Integration of x is x square upon 2 from 2 to 4. 2 and 2 cancel. Now let's find it out. So square of 4, that is 16, middle side negative. Let's put the lower limit. Square of 2 is 4 and therefore answer is 12. So guys, we got the line integral along BC as 12. Now let's find out the line integral along CA. So CA again, it's a straight line, so we'll be finding the equation of straight line using the same equation. So now I'll put the values of x1, y1, x2, y2 directly. So I'll consider this as x1 and y1 and I'll consider this as x2 and y2. So let's start. So guys, here I've substituted this 0, 2 as x1, y1 and this as x2, y2. But have you observed that when I substitute these values, here I got value as 0. And guys, whenever the denominator is 0, we get answer as infinity. So the question is, why we got the answer as infinity? So if you will see this line, then this line is parallel to x-axis. And we know that by the slopes of line, that a line which is parallel to the x-axis will have a slope equal to 0. Because whenever we find out the slope, we find the inclination of the line with respect to positive direction of x-axis. Now this line is never gonna intersect with the x-axis, so therefore by the formula of the slope, that is m equal to tan theta, theta will be 0, and therefore tan 0 is 0, so slope is 0. So guys, here we are getting 2 minus 2 0, and if I divide here itself, then I'll get infinity. But what we'll do is, since slope is 0, I'll shift this term over here, so that will become y minus 2 equal to 2 minus 2 0, it will come here, and it will multiply this term, that is x upon negative 4, so this whole term will become 0, and therefore we will get y minus 2 equal to 0, and that is y equal to 2. So this is the equation along CA. So guys, here I've used one method. Now I'll show you one shortcut method to find out the equation of line along CA. So here you can see that along the CA, the y coordinate, that is 2, and here it is also 2, so it is not changing. So if I extend this line to, let's say, on the right hand side or on the left hand side, the x coordinate will change, but y coordinate will always remain same, and that is equal to 2. So therefore we can directly say that equation of this line is nothing but y equal to 2. So here, this is also the standard formula of the straight line. So guys, instead of doing all this calculation, you can also say directly that y is equal to 2. Now I got y equal to 2, therefore I can say dy is equal to 0. So guys, let's put this value in the integral. So we have integration, that is, here I'll write down that integral for the curve CA p dx plus q dy equal to, now value of p is x square, so x square is gonna remain same, dx, then value of q is negative x y, so that minus x will be as it is, and y is nothing but 2, so that will become 2, and then we have dy, but guys, dy is 0, so here we will get 0. So this whole term will become 0, and we will get integral or integration of x square dx. So this is integration with respect to x, so we have to find out the limits of x. Now along CA, if you'll see from C to A, the x is varying from 4 to 0. So here I'll say x is from 4 to 0. So this is from 4 to 0. So let's find out integration, guys. So this is nothing but, it is equal to x cube upon 3, which is the integration, and let's put 4 and 0. So by substituting the upper limit, we will get 0 minus, let's put the lower limit, so that will give us 64 by 3, and that is nothing but negative 64 by 3. So we got the line integral along the CA. Now let's find out the total integral, and that is why we will add all these three values. So first value is 4, the second value we got as 12, and the third value we got as negative 64 by 3. So here I'll say, therefore integral along the curve C p dx plus q dy is equal to 4 plus 12 minus 64 by 3. So guys, you must be having Cal C, so this will give us this as 16 minus 64 by 3. I'll do the cross multiplication, we'll get negative 16 upon 3, and I'll call this as equation number 1. So we got the value of LHS. So guys, after getting this value of LHS, now let's find out the value of RHS, and for RHS will require these two values. So these two values we already got. So here you can see that I've already got the value of dou q by dou x as minus 1 and dou p by dou y as 0. So let's find out the RHS. So therefore double integral over the given region R, dou q by dou x minus dou p by dou y into dx dy equal to, so double integral, value of dou q by dou x is negative y, and value of dou p by dou y is 0, so I'll not put that value. And here, now guys, here we have dx dy. So let me tell you the importance of dx dy. So let's say if I'm writing dx and dy, it means I'm gonna integrate with respect to x first and then with respect to y. But what does it mean in the given diagram? So if I want to integrate with respect to x, then in this given curve we have to consider a strip which is parallel to x-axis. So let's say if you want to consider this as dy dx, then to find out these limits we have to consider a strip parallel to y-axis, because you are taking dy first. So now since we are going to take dx first and then dy, I'm going to consider a strip parallel to x-axis. So let's consider strip. Here I am showing you. So let's say this is a strip. So guys, you can see that this strip is parallel to x-axis. So we'll find out the endpoints of a strip. So whenever we take a strip parallel to x-axis, we have to check its x coordinates. So here this point is lying on the line BC, and along the BC we got the equation y equal to x minus 2. So guys, here I can say that the value of x is equal to y plus 2. So here along this line BC, I can say x is equal to y plus 2. Similarly, this point is on the line AB. So the equation of line AB here we got as y equal to 2 minus x. But I want the value of x. So if I take x here, it will become positive, and y there it will become negative, that is 2 minus y. So I can say that at this point the value of x is equal to 2 minus y. So we got x coordinates. Now guys, to find out the area, see here we are evaluating the double integral with respect to x and y, and this is nothing but the area of the given region. So guys, to find out the area of that given region, we have to find out the x coordinates and y coordinates of the boundary. So here what I did is I took one strip which is parallel to x-axis and I took its boundary coordinates, so which is from 2 minus y to 2 plus y. Now what we will assume is that strip is moving over this whole region. So let's assume that that strip is a flexible strip, okay, kind of a rubber band. So when it will move along the region, it will move till here, this point, and it will move till this line. So it means it is moving along the whole region, because that is the region or the curve which is given in our question. So when it will move from here to here, so we have to consider the extreme point. So when it will come here, this is the extreme point, lower extreme point, and this is the upper extreme point. So here at this point we have to check the value of y. So at this point the value of y will be 0, it is given, and at this point, since this is a line y equal to 2, the value of y will be 2. So I got two values, that is values of x and values of y. So we'll use this value. So here I can say the value of x is equal to 2 minus y to 2 plus y, and value of y is equal to 0 to 2. So guys, here we got the limit. So whenever we take dx first, we have to find out the coordinates of x in terms of y, and then coordinates of y, which will be the constants. But if we take dy dx, then we have to take a strip parallel to y-axis, and then we have to find out the limits of y in terms of x. Now guys, let's evaluate the integration. So here I'll keep this y from 0 to 2 as integration of y from 0 to outside, and now let's integrate this function with respect to x first. So that will become negative y into x, and this limit is from 2 minus y to 2 plus y into dy. Now let's put the upper limit. So we will get integration 0 to 2 as it is, negative y, which is a constant outside. If I put this value, we will get 2 plus y in x, middle sign minus, and then let's put the lower limit, which is 2 minus y, and dy as it is. Now guys, due to this negative sign, this will become minus 2, and minus 2 and plus 2 cancel. This will become plus y and plus y plus 2y, plus 2y into minus y is minus 2y square. So here we'll get it is equal to integration 0 to 2 minus 2y square dy. So negative 2 is a constant, let's take it outside. Integration of y square is y cube upon 3 from 0 to 2. Now let's find it out. So if I put upper limit as 2, negative 2 as it is, then we will get 2 cube, which is 8 upon 3, and if we put 0, we will get 0. Now multiplication of this is negative 16 upon 3. Now let's call this as equation number 2. So this is the value of the double integral, which is our RHS, and here we got the value of LHS. Now if you see the equation 1 and 2, then we got the same value, that negative 16 upon 3. So guys, here I can say that from equation number 1 and 2, the Green's theorem is verified. So guys, I'm sure that you understood how we got the value of the single integral or the line integral, how we got the value of double integral, and how we verified the Green's theorem. So this is how you have to find out, or you have to verify the Green's theorem in the examination. So I'm sure that you understood the explanation. So don't forget to share it with your friends, so they can also get benefited with the Green's theorem and the engineering mathematics. Thank you very much.